All right, class, so let's take a look here at your homework. And so in this homework assignment, they are asking you to conduct a linear regression based on two elements. We're looking at two variables. One of them is property size, and the other one is the taxes. So I want you to notice the way they're asking this question. They're saying after being hired as a financial advisor for a large real estate company, you have been tasked with exploring the trends between home size and property taxes to see if the relationship exists and if that trend can be applied outside of just the sample data. So we're going to begin with looking at some of this information. So there are your property tax and size variables. Now, I want you to understand they want you to select 10 randomly pairs. So obviously we have more than 10 pairs there. And so we're going to randomly select that. I'm going to walk you through that. So, and we're going to throw it into the Excel, which looks very similar to this. And then upon doing so, I want you to also notice this information right here and pay attention to this. Because this is randomly assigned, there's no chance that two students should have the same 10 samples. If you do, my first question is, did you copy? And that is unacceptable. There's no reason for this. If you're following this example video, you should be in a good position to answer these questions without issue. Now, in the report that you're going to generate, we're going to discuss all of these questions, and I'm going to walk you through each respectively. And I'm going to show you how to, first of all, randomly select your variables, your pairs. And I'm also going to show you how to use Data Analysis Toolpack. So let's begin with pulling up an Excel. So let me see what I have here. I might have already run it, so I may have to run it again. No, that's perfect. So I'm going to go ahead. I'm going to enable editing from here. And let me copy my original data that I had already selected. Okay, so let's go to the raw data here. So I'm going to start from scratch. Now, we're going to go to the tab on the bottom. If you notice, this is the raw data here. And we're going to randomly select the data. So here's what I'm going to do to make my life simple. I'm going to select numbers 1 to 10. So I'm going to literally go to the first pair. And I'm going to say equals rand between. That's this third one here. Double click on it. And I'm going to put 1, 10. So I want the first 10 to show up. Now you notice it's already generating numbers starting with 10, and I may not start with the 10. So if you look at my numbers, here's a 1. I'm going to start with the 1s, and I'm going to highlight them in yellow. So in this example, I have those. That's 3 already. And that's it for the, oh, here's another 1. That's 4. 4 ones. Okay, the next number in the sequence would be 2, right? So I'm going to go back to the top. Now I'm going to select my 2s until I hit 10 in total. So 2s, 2 to 2. There's other ways you can do a random selection, so keep that in mind. So I believe that gives me a total of 6. I need 4 more, so let me select the 3s. So 1, 2 more. That's 3. Here's another 3. Okay, so at this point I have 1, 2, 3, 4, 5, 6. I need 1 more to make 10, and there's your last value that you need. Alright, so there's my 10 samples. So if I count them out, just to make sure again, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in yellow, and that's what I want. So my data now, I'm going to go ahead and I'm going to literally delete that extra set here. I'm going to delete this. I have to stay in the columns. I have to keep reminding myself of that. Delete that. I'm going to delete these guys. Delete 1, 2, 3. Delete. And delete the bottom values here. Don't worry about the numbers changing. We already highlighted them. So we already know they're no good for us. All right, so these are the numbers I chose, and your numbers better not be the same as mine, because if you did that, you're not following directions, and you're going to get a 0. Okay, so I went ahead, copied it. I'm going to go back to my data, and I'm going to dump it. There you go. Okay, there's my property taxes and size. I may want to delete these 2 cells, so let me get rid of those 2, because I don't need the title twice. Maybe just delete that entire row. Okay. So this should still be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So here's the beautiful part about this. Understand that the way this is read is that the property size will dictate the property tax. So they actually reverse the x and y here, because this is your independent variable, the x. This is independent. And in other words, it tells the y what it's going to be. So the y is dependent on the x. The reason why I make that a big deal is because when you go to data, and we go to data analysis, and in this case we're going to go down to regression because we're looking for linear regression, it's going to ask you for the y and versus the x range, and it's important you put them correctly. So our x values are the size of the property, because that's going to dictate what the property taxes should be. Usually bigger properties have bigger taxes. I did include labels. I do want residuals, and I do want the normal probability plot. In terms of the output, we want the output to be in this cell here. So I'll go ahead and I'm going to hit OK. Remember, this is a video. You can pause it, rewind it as needed. All right. So here's my normal probability plot, which I'm trying to move without jacking up the entire table. All right. And so you see our correlation coefficient right here. This is our coefficient of determination. I'm going to label these and discuss it with you. Here's the significance level. These are all elements we need to answer these questions. And this will give us the linear equation we're looking for. Down here you have the residual plot, the probability output, which is also good to know, and another graph you can actually pull out. Okay, so let's begin answering the questions in your homework. So let me do this side by side so that I can discuss each respectively. So we're going to begin with this first question right here. Interpreting the correlation coefficient. That tells us how strong the association is between 2 variables. Now remember, correlation coefficient runs between -1 and +1. So the closer it gets to 1 and +1 or -1, the stronger it is. So I'm looking at this multiple R. This is the correlation coefficient. And this is the R, which is equal to, in our case, 0.87. It tells us the direction and the strength of the association. So what I would say here is, in terms of interpreting this, because they're asking you to interpret it, we would say there is a strong and positive, because it is a positive 0.87, association between property size and property taxes. Okay, so that is the first part of what you need to interpret there. Let me just open this up for a moment so you can catch that in case you need to pause the video. Now, if I took 0.8715 and I squared it, that's how we obtain this number, which is the coefficient of determination. That's all it is. It's r squared, literally. So coefficient of determination is interpreted as r squared, which is also interpreted as a percentage. Now, because this is 75.95, I would say that this is, let me just go with 75.95% of the variation, because that's what the coefficient of determination is all about. It's all about the variation between the two variables in the model. So 75.95% of the variation present in the model can be explained by variations present in X. In our case, property size. All right, and so that's the interpretation of that, even though it's not necessary. That answers the first question. That's all we've answered thus far, is that question right there. Interpret the correlation coefficient. Now, when we talk about the second question, which is this one here, discuss a hypothesis in order to determine whether the population correlation between the two variables differs from zero. Okay, to answer that question, I want you to think of two things. First of all, let's talk about the null hypothesis. The HO, which basically says, in this case, there is no association between property size and property taxes. Okay, in other words, R is, or rho is equal to 0 in our case. That's what they're referring to. Our alternative hypothesis, and this is not going to vary for us in terms of writing this down. This part is going to be the same. This is our H1 or HA, is depending on how you label it. Here we would say there is an association present between property size and property taxes. Okay, so that is going to be uniform for the two of us. Now, when we discuss a hypothesis, what you're going to basically, in essence, also discuss here is with respect to the actual numbers. So I want you to refer back to the table when you're discussing this question. And you're basically going to talk about what's happening here between the size and the property tax. So as an example, I'm looking at 2400, which is only a 200 square foot difference between that value, and there are approximately another 200 square foot difference here. And so while I see that there's some consistency, this is 22,907. This is a huge drop. That's a $7,000 difference. So I want you to sort of talk about those things with respect to this. But technically, even though you're going to do that analysis, you're still looking at these two as being the same for all of us. All of us are going to have the same null and alternative hypothesis. Now, what I want you to now focus on, having said that, and you having discussed your information, is this. What are the results of the hypothesis test in the context of this task using a 5% significance level, which means that alpha is equal to 0.05? To answer that question, I want you to focus here at this number. That's your p-value. So you have a p-value, in this case, equal to 0.001019. You have an alpha value, which in this case is equal to 0.05 because they said 5% significance. Remember, the rule is if p is less than alpha, we're going to reject the null. If I reject the null, I say no to this, no to this, yes to this. Yes to the alternative hypothesis, which says that there is an association between the property tax and property size. Okay, and that's what you just proved it right here using that number. I'm going to go highlight this for you in let's go with yellow just to make it stick out. Now, in this one, they're asking for the actual regression equation. To answer the regression equation, I want you to focus right here. I'm going to highlight this for you in let's go with green. Okay. And so this is your regression equation where you say basically predicted y, which is this symbol right here with a little caret on top, is equal to 5,867.37 plus 6.806232x. X is our, as I discussed with you earlier, that is our property size. So go back to the original notes, and I said to you that in this model, our x is independent of y. It's predicting y. It's helping make the prediction for y. So if I'm using this model, I don't know why that moved down, but let me go ahead and put it back up here. This is 6.08, 6.08, 6.806232, and this x is what we're going to substitute in. So that's your equation. That actually answers that question. And what this tells me is that for every increase of 1 unit in x, there's going to be an increase of approximately $6,000, 6,800, because remember, this isn't thousands, so is this. There's going to be an increase for every increase of 1 unit in x, there's an increase of 6,800 in y, predicted y. That answers that question. And to explain to you how we use that, this is what this question is doing. Use this predicted value for property tax. Use this to predict the property taxes on a home that is 1,500 square feet. So basically, to answer that, we're going to say this equals 5,867.37 plus 6.806232 times 1,500. Hit enter, and that's your answer. So a property that has a size of 1,500 feet should cost $16,076.72 of property taxes. That's how we predict this value. Now, before I continue this assignment, now remember, you have a lot of elements that you're going to discuss here. So it's a pretty easy assignment. I'm giving you everything you need. Just remember, our numbers are never going to be the same. What I do want to talk to you is the two definitions, and I also want to show you first, before I even begin doing that, let's talk about the scatter plot. So if I go to insert on the Excel sheet, highlight this property tax and size, and hit this for the scatter plot. And be careful when you input this because it may mix this up in terms of size, the series. So we need to know where the X and Y are sitting. Because if we reverse this, this will give us a different explanation. We could change the chart. We could change the XY values. Let me see here. There's also a website called alcula.com, by the way. Alcula.com is an online scatterplot creator, so it'll do the linear regression for you. So if I go here and I select my values, so these are my values, and this time to only select the numbers for Alcula, the Alcula website, literally drop them in. I have to collect the copy, select control copy, go to Alcula, drop them in there, submit the data, and it does give you the linear regression. I must have missed a number. Oh, I know why, because it's scrambling the x and y values. They're actually reversed. Let me go back. So I would have to maybe do this. Control copy, bring this on this side. Control paste, because this is how we have them listed. Control copy, go back to Alcula, and yes, it is a little sensitive. Let me go back to linear regression. I'll do it again. All right, I'm going to drop the data. It should be the same thing we have now. There you go. Same thing we had. There's your scatter plot. Okay. I believe it does look very similar to what we obtained initially. Let me just take a look here. It kind of looks the same. It should be identical, technically. Let's look at them side by side just for the sake of comparison. Yeah, you kind of do see the cluster. You do see that. Their scaling is a little off, or a little different, but for the most part, we have pretty much the same. We do have the equation here. So this is, if you feel more comfortable copying and pasting this on for your assignment, you can. All right, and there you go. I don't know what I just did there. Put that back. All right. There's two other things I want to discuss with you, and they are two definitions that sometimes stats teachers and books don't really get into that much, but you need to know this. The two words are interpolation and extrapolation. Now, the reason why these are important is interpolation is an acceptable use of the data. And it means that the value used to predict or the model, or to use as part of the prediction, input for the prediction. Let me say this way. The value used as the input is within the domain of the original data. Okay, so that is acceptable. So that's interpolation. Extrapolation is not as acceptable. This x values, or the domain values, are outside. I would say fall outside of the original domain of the model. Okay, what do I mean by that, first of all? Because you probably don't understand that as I explain it. So let me go back here. Let me just look at the domain. Now we've said x was the size, so that's our domain values. Let me get rid of this so it doesn't confuse you. So these are our x values, right? You do notice that if I were to sort this column, so let me just sort it for the moment. Let me see if I can do this. Okay. You notice how your lowest value is 1330, your highest value is 5,602. So interpolation is anything between 1330 and 5602. So if I chose, for example, 2000 as this is not subtraction. There. 1330 to 5602. So a number like 2000 falls within there. That's an interpolation. So if I choose a property that has a size of 2500, for example, that's an example of an interpolation. And yes, I can use that to predict the model. That's okay. That's good. It's acceptable. It's something we would trust. But if I chose a number like 6500, 6500 is an example of an extrapolation and not necessarily reliable, because an extrapolation is not part of the original model or domain for the model. Remember, the domain is determining this model, this equation, the linear regression equation that we obtained in the green. That was created based on those input numbers. Anything else is not acceptable. So when we talk about this, interpolation is good. Think about it as good and bad. Extrapolation, not reliable. That's bad. Okay? So in the report, just remember to maybe add a reference, use the diagrams. I did talk to you or show you that you can do the normal probability plot, and you might need to do a little bit of research on what the normal probability plot tells you. I would suggest that in this case, this is pretty strong, pretty good. Doesn't necessarily have a shape. Now, the one you really do need to pay attention to, and let me just go back because I don't know why it did not show up on my report, but we'll do it again, is the residual plot. I want you to see this residual plot for a minute. Let me see. Where's my residual plot? No, it's the normal probability plot. This is what I need right here. I want you to look at this table right here in the middle. You see how it's like random, it's totally scattered about? That is what you want. You want this to be as possibly random as possible, because if it has a shape, it's not good. It's not a good example of use of the data. So if this had a shape like a circle or a parabola, this residual plot, you notice, is totally scattered. I want you to include this in your report, by the way. And your commentary is very simple. It's just tell me what you see in the dots. Do you see a pattern in the dots? There shouldn't be a pattern. There should not be a pattern. The other thing I like about this particular one that I have here is also, if you notice, you have almost the same amount above as you do below the line. That's another good indicator. It's also scattered. There's no shape. Those are the things you're going to literally mention in your report. Okay, and for the most part, you have everything you need. Just do a nice write-up and we're done. Hopefully I hit record and I don't have to do this yet again.